with your learning targets. By the end of this lesson, you should be able to solve a systems of equation using substitution, all right? And then you'll be able to solve it using your calculator. So you'll have the choice by the end of the lesson to either solve this using mathematics or to solve it using your graphing calculator. So for the first one, it says use substitution for this system of equations. Let's remember that a system of equations is simply two equations, not just one. We have two to use, and we want to kind of use one in for the other one. Again, we're substituting. So when this is saying y equals, it's basically telling us that this right here is the same as saying y. My classic example for this is if I had $10, I could have $10 a few different ways. I could have a $10 bill, which is kind of like what this is. All right, just 10 bucks. And then this could be the combination of, maybe a $5 bill plus 5 single dollar bills, okay? It's just a different way to express the same thing. Both mean $10, all right? Whether you have one $10 bill or 1 5 and 5 singles. So hopefully that helps us understand that when I see this, I can substitute it in for this because they mean the same thing. And so what I do is I rewrite the equation with this in it. So I'm going to rewrite this bottom equation here as 2x plus, but not y, 2x plus 3 equals 7. And that's the only new step. So if you have any questions on that, please let me know, because everything else we're going to do is basically solving an equation. All right? So once I've done that, it's pretty simple here. So a real quick review. Combine like terms if they're on the same side. 2x and 2x make 4x plus 3 equals 7. Now we got it down to a two-step problem where I subtract 3 on both sides. I end up with 4x equaling 4. Divide by 4 and x is equal to 1. So there you have it. We have solved for the x value. Now, that is not the end. We always want to solve for both x and y. So once we've solved for one variable, it actually makes it much easier to solve for the missing variable, in this case y. Now, we get to choose which equation we want to work with. So when we're given the choice, always try to choose the easier equation to solve for y, and that would be this one right here, which is already solved for y. So I'm going to take the equation y equals 2x plus 3 and substitute in 1 for x. Why is that? Because I just solved and know that x is equal to 1. So this ends up being y equals 2 plus 3 and a y value of 5. Now again, we're talking linear equations, which could be graphed, so we could write this as the point 1, 5, the x value and the y value. And we'll see what that means in a little bit when we start using our graphing calculator. So with these, some of them are a little bit more simple than others. In this case, I don't have either equation solved for a variable. So sometimes it's solved for x, sometimes it's solved for y, and in this case, we've kind of got too much information over here and way too much information over here. So way easier to kind of take this and solve it for y. So you just kind of have to have some practice with this in order to kind of identify which one is easier to solve for. So in this case, it's much easier to solve for the y by just subtracting 3x. A lot of equation skills here. You got to be good with those. So this ends up being y equals, don't subtract terms that aren't alike, so simply write it as negative 3x minus 4. So now I've done what I talked about earlier with this kind of being the $10 bill and this kind of being a $5 bill plus 5 singles. So they mean the same thing. If I say y or if I say negative 3x minus 4, they don't look the same, but they certainly mean the same. So what I want to do is take this expression, okay, what is considered to be y, and use it into the other equation, because remember, we've got two equations or more when we're dealing with a system. So I'm going to write that new equation with the 2x still, that doesn't move, minus 3 because that's got to stay, but now I've got to put in that new expression, which is also known as y. So I'm going to use green for this, negative 3x minus 4. Now there's one thing we've got to remember to do. Because that's all y, we want to put this in parentheses. All right, we want to make sure that everything gets multiplied by the negative 3, and then it's still equal to negative 21. So there we have our new equation with just one variable. That's so important that we can't solve an equation with two different variables, but we can clearly solve this one with just one variable. So I'm going to start with distribution. We've done equations like this, so this should be just a review of using the distributive property. Remember, this is a negative times a negative, so positive 9x, and then do it again, a negative times a negative 4 for a positive 12 equaling negative 21. Don't forget about the 2x that was out in front. You know, very typical for students to maybe think about subtracting here, but again, they're not like terms, and distributing, multiplying before subtracting. Now, we've got like terms here, so go ahead, put those together when they're on the same side of the equal sign. 11x plus 12 equals negative 21. And we're rolling here. At this point, it's a two-step equation that most of us should be very skilled in. So 11x equaling a negative and a negative, so this is going to be added up for a negative 33. Divide by 11, and this is going to work out very nicely as x equaling negative 3. So, you know, typically we're going to get integer values. We're not going to get decimals or, you know, crazy fractions when we're dealing with this. All right? So we have successfully solved for x. Now it's important for us to go back and find y. And we get to choose which equation. And if we're going to choose an equation, why don't we choose one that's easiest to use? And if we're looking for y, there it is right there. Use this one. All right, so the y equals negative 3x minus 4. All we're going to do is kind of slide in this number for x. Again, this is the substitution method. And obviously we're doing a lot of substitution today. So a negative 3 times a negative 3 is simply positive 9 minus 4, which is going to end us at 5. So again, this is a point on the graph, which we'll see in a moment when we graph these. Negative 3 for the x value and 5 for the y value. So there you have it. You have found both x and y using the substitution method. You want to make sure that each equation has been solved for y. In our first example, we already had one of these. This was solved for y equals, so that equation is good. This one, not so good. I have a little bit left to get y by itself. So all I'm going to do is simply subtract 2x on both sides. This zeroes out. And now y equals, don't add unlike terms or subtract them for that matter, negative 2x plus 7. So I've got 1 and 2 equations that have been solved for y. Now, put both equations into y equals, and then we're going to try to find where they intersect. So, to do that, I press y equals and enter what I've solved for. So the first one was already done, 2x plus 3, and the other one was a negative. So when you have a negative, make sure you use this button down here underneath the 3, and that is 2x plus 7. So it's the same problem, but we're using the calculator to solve it, and now we want to find where they meet. And I don't want to just kind of look at the graph. I want to find exactly where they meet. So you press second and trace. And that brings up these options. Now, where they meet is where they intersect. All right, so that's option number 5. So either scroll down or hit option number 5. It will graph both lines for you. Now, if you're using Desmos right now, you're going to try to find where they meet. And you can just take your mouse and just kind of move it to see where they meet. Now, I have a little flashing spider here. Okay, so Spider-Man, we need to move to where they meet. So we can move it left or right. In this case, moving it to the right slides it up, and it basically puts it right where they meet. And that's when you want to press enter 3 times, because it's going to guess. So the first curve, the first line, it's guessing that. Then it guesses the second curve, and then it guesses the final answer. So there it is, an intersection of 1, 5, which again is the same answer that we've already got. We got the answer right here by using the substitution method, or we got it by using the calculator. So all those directions on how to do this are on this set of notes. You may not have that in your copy. So you might want to write down this information into your notes, okay? So how can we use the calculator to solve example number 2, which we've already done? Again, same steps. Solve each equation for y. Now when they're stacked like this, it's kind of annoying, right? It's kind of annoying that I can't just solve it underneath, but I got to just maybe break it up a little bit. Y plus 3x equals -4. So small step, not a big deal, just a nuisance really. Subtract 3x on both sides. Y equals -3x minus 4. Done. Solve for y. And maybe you find that to be less work than trying to substitute it and solve the equation. You get to kind of choose here. Now we're going to take this equation. Do the same thing. This one's got a few more steps in it, but again, remember the goal is to solve for y. This is excellent practice to put something into slope-intercept form. This is a skill that we've already practiced, so hopefully we're pretty good at it by now. But we want to subtract 2x on both sides, -2x minus the 21 that was already there. Again, don't add or subtract unlike terms. Now we want to divide by -3. Remember, everything gets divided by -3. Oops. And this is going to give us 1 here, so the y by itself. It's a negative divided by a negative, so it's really a positive, but I'm not going to make it a decimal. I'm going to leave it a fraction, leave it a rise and a run, and then a negative divided by negative is positive, and 21 divided by 3 is 7. So there you go. You've got both equations solved for y, which now you can put into the calculator and solve the system of equations. This is a great kind of skill to know. So let's pull the calculator back up. Let's clear out my history, and let's clear out y equals. So let's get rid of these equations by pressing the clear button. Once you've got a clean slate, you want to enter the equations that you solved for. So that was a -3x minus 4. Notice how I used the negative button when it was in front of the number to start it, but I used the subtraction button. You can't get those confused because if you do it in the other order, it will make it wrong. It will not graph it. And then the other one we solved for was 2. Make sure the x goes in the top, and then simply divide it to make the fraction over 3. So that is the fraction 2x over 3, a rise of 2, a run of 3. X has to be in the top, and then add the 7. And once you get the hang of this, it's really easy, but you want to press second trace. And all this information was written down for you on the notes, and you want to find where they intersect. You can kind of clearly see that they do meet. So press number 5. It graphs the first line, it graphs the second line. Hopefully on Desmos, we can talk about this in a little bit if you're using Desmos of how this works. But we see the little spider guy here. This time, I've got to move it to the left. And as I move it to the left, it moves up the line. Now if I just use the up and down arrow, all that's going to do is cause it to jump back and forth from one line to the next. So that's why you got to move it left or right. Now this is just where we've kind of landed it. We want to make sure the calculator comes up with the answer by pressing enter 3 times. Not once, not twice, but 3 times is the charm, and bam, -3 and 5 for the y value. Again, the same answer that we've just solved for, -3 and 5, so a good way to check. But using the calculator will give you the same answer as using the substitution method. Okay? So -3, 5. And there you have it. 2 ways to solve a system of equations.